Hello everyone. Our lesson today is an introduction in complex numbers. First, remember the set of numbers. We studied before the natural numbers, which contains 0 and positive numbers. We didn't find the negative number in natural numbers, so we get the integer numbers z. We get 0, positive numbers and negative number, and didn't found the fractions and the decimal, so we get the rational numbers q. Q contains 0, positive numbers, negative numbers, and fractions and decimal. Okay, then we get the real numbers, which contains q and q dash. Q dash contains root 3, root 4, root 5, and so on. Okay, and we said before, natural numbers subset, integer numbers subset from rational numbers, and subset from real numbers. Okay, today inshallah we will study a new set of numbers which is called complex numbers. Okay, how to solve root -4? We called it undefined. We didn't have a solution. In this year we get a solution for square root of -4. It will be square root 4 times -1. Separate 4 and -1. Okay, and also separate the square root. We get square root of 4 multiply square root of -1. The square root of 4, it will be 2, and the square root of -1, we called it I, and I in the set of complex numbers. So the set of complex number contains rational numbers and I, so we get the real number subset of complex numbers. Okay, so we get I equals square root of -1. We have a table, it's very important. I power 1 equals I. Okay, I power 2. I power 2 equals the square root of -1 all power 2. The square root cancel power 2, it will be -1. So I power 2 equals -1. Okay, I power 3 equals I power 2 times I. We said I power 2 equals -1. So -1 times I, it will be -I. Then we get I power 3 equals -I. Okay, I power 4 equals I power 2 times I power 2. I power 2, we said -1 multiply -1. We get -1 times -1, it will be 1. So I power 4 equals 1. In general form, I power 4 in multiples of 4, like I power 4, I power 8, I power 16, and so on. The result equals 1. I power 4n plus 1, separate the power. So I power 4n equals 1. I power 1, we said before, equals I. Okay, I power 4n plus 2, the same. I power 4n equals 1. So I power 2, we said before, equals -1. Finally, I power 4n plus 3, separate also the power. I power 4n equals 1. I power 3 equals negative I. Okay, for example, how to simplify I power 33. First, divide the power by 4. Our power equals 33. 33 divided 4. By using your calculator, it will be 8 and decimal numbers. We get the whole numbers, which is 8. 8 multiply 4. It will be 32. Our power is 33. So we get 33 minus 32. It will be 1. 1 is a power. So the result of I power 33 equals I power 1, which is I. Okay, first divided the power by 4. Get the whole number times 4 equals 32. Our power minus the new power equals 1. So our new power equals 1. So I power 1 equals I. Okay. How we can write the complex number? The complex number write in the form A plus BI. A is a real part and B is an imaginary part. For example, 3 plus 4i, 7i, and 2. So the complex number contains real part and imaginary part, or imaginary part or real part. We said before, the set of numbers we studied before, all of them are subset of the complex number. So 2 is a natural number. We said natural number, subset of the complex number. Okay. In general form, the set of the complex number set is defined as A plus BI. A belongs to R, B belongs to R, and I power 2, we said before, equals negative 1. I power 2 equals negative 1. We have an example. Find the solution set of 2x power 2 plus 18 equals 0 in the set of complex number. We have an equation, 2x power 2 plus 18 equals 0. All your aim is to get x in one side alone. So we move 18 into the other side by opposite sign. So 2x power 2 equals negative 18. Divided by 2, x power 2 equals negative 9. Take the square root of both sides. So square root of x power 2, it will be x equal, don't forget positive or negative, square root of negative 9. X equal positive or negative, we said before, negative under square root, it will be I. And we get square root of 9i. The result will be 3i. Therefore, the solution set equals 3i and negative 3i. Okay. Equality of two complex numbers. Two complex numbers are equal if and only if the two real parts are equal and the two imaginary parts are equal. For example, if A plus BI and C plus DI are two complex numbers. And if A equals C and B equals D, the real part equals the real part and the imaginary part equals the imaginary part, we get the two complex numbers are equal. And vice versa. If A plus BI equals C plus DI, we get the real part equals the real part, A equals C, and the imaginary part equals the imaginary part, b equals d. For example, find the value of x and y where x plus yi equals 2 plus 5i. We get the real part equals the real part, so x equals 2, and the imaginary part equals the imaginary part. We get y equals 5. Okay, adding and subtracting complex numbers. To add and subtract the complex numbers, we add or subtract the real parts together and add or subtract the imaginary parts together. For example, find the result of the following in the simplest form. 3 plus 7i power 13 plus 5 minus 9i. I power 13. Take the power divided by 4. 13 divided 4 equals, it will be 3 as a whole number and decimal. We get 3 times 4, it will be 12. يبقى 13 minus 12 equals 1. So I power 13 equals I power 1. Then 3 plus 7 I power 13, it will be I plus 5 minus 9i. Add the real parts together. So we get 3 plus 5 together plus the real parts together, 7i, minus 9i. 3 plus 5, it will be 8. 7 minus 9i, it will be negative 2i. Okay, multiplying the two complex number. Two complex number can be multiplied just as the algebraic expression, and consider I power 2 equals negative 1. For example, we studied before the algebraic expression in first prep. How? Find the result of the following in the simplest form. 4 plus 3i multiply 2 minus 5i equals 4. Separate 4, multiply the bracket, and 3i multiply the bracket. 4 multiply 2 minus 5i plus 3i multiply 2 minus 5i. Okay, equals 4 times 2 equals 8 minus 20i plus 6i minus 15i squared equals 8 minus 20 plus 6 in your calculator, it will be 14i. I power 2 equals negative 1. So negative 15 multiply negative 1, it will be plus 15. 8 plus 15, it will be 23 minus 14i. Okay, the conjugate of the complex number. The two numbers a plus bi and a minus bi are two conjugate numbers. So the conjugate number difference in the sign. Okay, for example, find the conjugate numbers of 5 minus 7i. Change the sign, it will be 5 plus 7i. Okay, 4i plus 3. First order the complex number, the real part first, then the imaginary part. To get the conjugate number, it will be 3 minus 4i. Number 3, 3. We have a whole number, it will be 3. The conjugate number, change the sign of the imaginary part. Simplify to the simplest form. 3 plus 2i over 2 minus 5i. To get this expression in the simplest form, multiply up and down by the conjugate number of the denominator. Multiply by 2 plus 5i over 2 plus 5i equals 3 times 2 equals 6. 2i times 2, it will be 4i. 3 times 2 equals 6. Okay, 3 times 5, it will be 15i. 2i times 5i, it will be 10i squared. In the denominator, 2 times 2, it will be 4. Difference between two squares, first times first, negative, second times second. 5i times 5i, it will be 25i squared. Okay, I squared equals negative 1. 6 plus 4 plus 15, it will be 19i. 10 times I power 2, it will be negative 10 over 4. 25 times negative 1, it will be negative 25, and the sign negative, it will be plus 25. 6 minus 10, the whole numbers equals negative 4 plus 19i over 29. Separate negative 4 over 29 plus 19i over 29. Thank you.